Ever wonder how an app just knows you're old enough to vote? Or how a playlist can instantly sort all your songs alphabetically? Well, the answer to both is actually the same, and it's this simple little secret hiding in plain sight. Today, we're going to pull back the curtain and look at the core logic that lets computers make decisions.
It really all comes down to this one question. Behind the most complex software you use every day, your banking app, your social media feed, even a self-driving car, is a computer just asking and answering this exact question millions of times in the blink of an eye.
So here's our game plan for this explainer. We're going to start with the basic concept, then we'll meet the tools of the trade, see them in action with some code, connect it all to the real world, and then we'll see their incredible power in the world of data science. All right, let's start with the secret itself. How do computers actually, compare stuff? The answer to that big question is right here, relational operators. You might also hear them called comparison operators, which is a great name because, well, that's exactly what they do. Their entire job is to just compare two things. That's it. And here is the absolute key to everything. No matter what you're comparing, the answer can only ever be one of two things: true or false. It's what we call a Boolean result. I mean, think of it like a light switch. It's either on or it's off. There is no in between. This simple binary choice is the foundation for all logic and programming. So what are the tools in this comparison toolkit? Turns out there are only 6 of them, and you probably recognize most of them from math class.
And here they are. You've got your greater than and less than. Pretty straightforward. The one to really pay attention to is equal to. See how it uses a double equal sign? That's super important because it tells the computer we're asking a question. Are these equal? Not giving it a command. But yeah, that's the whole set. These 6 symbols are all a computer needs.
Okay, enough theory. Let's actually put these operators to work and see what happens in some simple code. We're going to keep this super simple. Let's just pretend we have 2 variables. We'll call them A and B, and we'll set A to 10 and B to 20. Okay, so if we ask the computer, hey, is A less than B, which in code looks like this, we're really asking, is 10 less than 20? And of course, it is. So the computer just gives us the only answer it can, true. So what happens if we ask if A is equal to B? Using that double equal sign, we type this out. Is 10 equal to 20? Nope, not a chance. So the computer comes back with false. And that's the whole point. The result is always a crystal clear, unambiguous, true or false. Now, this might seem a little abstract, but these simple true or false answers are what drive decisions you've run into every single day. Let's connect the dots. And get this, it isn't just for numbers. This is exactly how alphabetical sorting works. See, behind the scenes, every letter has a numerical value. So when the computer compares apple and banana, it's really just checking if the value for A is less than the value for B, which it is, so the whole thing is true. Or think about any website that asks for your age. The logic looks just like this. The code checks if your age is greater than or equal to 18. If that comparison comes back true, it runs one piece of code. If it's false, it does something else entirely. It's a decision based completely on one of our relational operators. All right, now for the really exciting part. Let's see how these incredibly simple building blocks are used to power one of the most complex and important fields out there today, data science and machine learning. In machine learning, these simple comparisons are the unsung heroes. I mean, they're used for everything. Cleaning up messy data by filtering out errors, helping an AI decide what information is most important, and even judging if a prediction, like spotting a cat in a photo, is confident enough to be trusted. Let's look at a classic example. We're using a popular data tool called Pandas, and we've got this simple little table of test scores for Anna, Bob, and Charlie. Okay, now let's say we only want to see the students who passed. We can write a single line of code that tells the computer, look at the score column and only keep the rows where the score is greater than or equal to 70. And there it is, a relational operator, doing all the heavy lifting. And boom, just like that, we get our result. This shows the power perfectly. Bob and his score of 42, he's gone. The code looked at each row, returned true for Anna and Charlie, false for Bob, and just handed us our new filtered list. So there you have it. We've gone all the way from a simple true or false answer to filtering gigantic data sets. Relational operators really are the fundamental building blocks of how machines make decisions.